Hello dear students, in this video we are going to cover the entire lesson of class 10 science, that is electricity, in very short time. Okay, let us go with very much rapid revision. Okay, now let us take this. First we need to understand what is electric current. Electric current is nothing but the amount of charge flowing across the cross-sectional area of a given metallic conductor in unit time. That is what we call what electric current, and it is denoted by I. I is nothing but Q by T, because Q is the amount of charge flowing what in unit time, so that is T. So that is why SI unit of current is what? Ampere, right? Next, coming to amount of charge. If you want Q is equal to N into E. E stands for what? Charge of one electron. This is a number of electrons. When you multiply, total amount of charge you will get, right? Next, coming to 1 coulomb. 1 coulomb means what? It is 6 into 10 to the power 18 number of electrons. When they are multiplied by charge of 1 electron, you are getting 1 coulomb of charge, right? Next, the device used to measure the electric current is what? Ammeter. Ammeter is always connected in series in a circuit. The SI unit used to measure the electric current is what? Ampere, remember. And we need to understand what is 1 ampere. 1 ampere is nothing but in 1 second 1 coulomb of charge flows. Then we can say the current is said to be 1 ampere. That is what we have written here. And ammeter is always connected in series in an electric circuit, right? Yes. Next, coming to electric potential difference. What is electric potential difference? It is the work done to move a unit charge from one point to the other in an electric circuit. We call this as what? Electric potential difference, right? Yes, it is denoted by phi. Phi is equal to Q by what? W by Q. Okay, W means what? Work done divided by charge. Okay, how much work we are doing to move that unit charge. That is what it is giving us what? Uh, Potential difference. Next, coming to the SI unit used to measure that potential difference is volt. Okay, the device used to measure that potential difference is voltmeter, right? Remember, voltmeter is always connected in parallel in a circuit. Okay, and we should also understand what is 1 volt. 1 volt is nothing but it is 1 volt means W by Q we are taking, right? W means joule, Q means charge. So joule per coulomb. How? 1 joule per 1 coulomb. Okay, that is what it is giving 1 volt. Okay, so that is what 1 volt is for 1 joule per coulomb. Next, coming to here, electric component and the symbols used. The electric component, this is cell, this is battery, this is switch or plug key, it is open, this is closed. Okay, this is switch on, we can say. This is wire joint, wire crossing, electric bulb, resistance, this is variable resistance or rheostat, we can say. This is ammeter, this is voltmeter. Yes, next coming to here Ohm's law. What is Ohm's law? It is very simple. The potential difference across the ends of a given metallic wire, okay, in an electric circuit is directly proportional to the current flowing through it, provided the temperature remains the same, right? So this is how we need to define that full. And the mathematical expression is nothing but phi upon I is equal to R. Means what? If you divide that voltage, means potential difference by current, you are going to get that constant. That constant is resistance. What is the resistance then? Resistance is nothing but it is the opposition offered to the flow of electrical charges in a given metallic wire. Remember, right? This is, and 1 ohm also, if you want to divide here, if you want to define here, what we can say here, phi upon I is equal to R we are taking. Phi has to be 1 volt, current has to be 1 ampere, then it will become 1 ohm. And the SI unit of resistance is ohm. Okay, it is denoted by the letter, Greek letter here, like this symbol. Yes. Next, coming to resistance we already defined. Next, coming to factors on which the resistance depends. It's very simple. As the length increases, resistance increases. As the area of cross section increases, resistance decreases. Very simple, right? And as the temperature increases, resistance again increases, because particles will be colliding with each other. Next, depends on the nature of material also. What resistance depends. As you change the material's nature, then also it changes, remember. Next, this is all about factors on which the resistance depends, we can say. Next, coming to here, resistance we already defined. The mathematical expression for resistance is what? R is equal to rho into L by A. Rho stands for resistivity. Resistivity means it is also property of the material by which it opposes the flow of electrons inside it. Okay, that is what is called resistivity. This is taken as L upon A. Okay, this is what is it is standing for. Each letters I have already written here. How we are getting this formula I have written here, right? So it's very simple. Next, coming to here, resistivity just by changing the terms we are getting this rho is equal to R into A upon L into terms. Okay, If it is a resistance, it would become L by A. But here resistivity means R into A by L it becomes, because we are shifting the term. So that is why it is changing. Next, coming to here, series combination of resistances. We need to understand which factors will change, which factors remain constant in a what series circuit it may be, parallel circuit it may be, of resistors. Coming to here, changing factors. Here, when you connect resistors in series, potential difference breaks into V1, V2, V3, and so on. Okay, it divides. Whereas resistance will be constant, current will also be current. What a constant in a what series circuit of resistances? Remember. Next, coming to here, if you want equivalent resistance, what is that? When you can replace all the resistors by one resistor, that is called equivalent resistor or resistance. That can be identified. How it can be calculated? The sum of all these resistors will be equal to that equivalent resistors. That is what we have derived this formula here. Okay, that is Rs equal to R1 plus R2 plus R3. Rs stands for resistors in series. Next, coming to here, what parallel combination of resistances? Here, or what factors will change here also, we need to understand here. In parallel combination, current divides as I1, I2, I3 and so on, but potential difference remains constant because each resistor is directly connected to the source of electricity. Okay, so that you have to remember. And resistors, they are constant, you know that already. So next, if you want to calculate what is the equivalent resistor, means instead of all these three, we can replace one more resistor, that is equivalent resistor. If you want to calculate what is that, it's what quantity, just you can say 1 upon Rp is equal to 1 by R1 plus 1 by R2 plus R1 by R3. This is the formula by which you can calculate that equivalent resistor or resistance. Next, coming to here, power. If you want to calculate the power, here mathematical expression I have given here. Power is nothing but it is the energy, how much energy it consumes given electrical gadget in a given time. That is what power. Power you can calculate by using these three formulae, out of which whichever you can use, it gives what power. For example, in potential difference current, here potential difference square divided by resistance, here current square into resistance you can do, so that you will get power. Next, coming to here, Joul's law of heating. Okay, Joul's law of heating means when a current passes through any metallic conductor, it produces some amount of heat that will be wasted in the form of waste energy, we can say there. It will be dissipated unnecessarily. So that is why mobiles, any laptops, computers, every electrical gadget gets heated up because some amount is being wasted there. So this is what defined by joules. Okay, so here he had means just we are purely taking resistor here. Okay, to define that Joule's law of heating there. So if you are taking resistor and defining, here what we can say here, heat produced means resistor means it gets heated up using entire electrical energy. The heat produced in a resistor is directly proportional to the current square of the current passing through it. Okay, and it is directly proportional to the current time for which electric current is passed. How long you pass current, that much it gets heated up. So next is what? Heat is directly proportional to the resistance of that material. If the material's resistance is high, more heat. If the resistance is low, less heat. Okay, you can remember this. For example, tungsten, it is resistor, that is why it gets heated up soon. Whereas copper, it does not get heated up because its resistance is very much low as compared to tungsten. Tungsten is used in what? Electric bulbs as filament. Okay, when it starts glowing, it gives light. You know that already. And it is covered with bulb casing, and that inside that argon gas will also be filled in order to avoid what oxidation of that filament. It reacts with oxygen and it burns. In order to avoid that, argon gas is also filled into that. And usually alloys are preferred for making these what resistors, because they do not get oxidized easily. Okay, as compared to individual metal, remember, and their resistance will also be higher as compared to their individual materials, you can see. So this is all about Joule's law of heating, that is H is equal to I square RT. This is the expression for Joule's law of heating, remember. Next, coming to here, calculation of electrical energy. Means what? If you are operating any electrical appliance for so long, means how much energy it is consuming. If you want to calculate, this is the formula. Energy is equal to power into time. Means what power it has, how long you are using it. If you multiply both together, you are getting the electrical energy consumed by that electrical gadget. Next, coming to energy will be what measured in terms of unit. One unit is nothing but it is 1 kilowatt hour. 1 kilowatt hour means what? 1000 watt. Okay, if it is consumed. Okay, 1000 watt if it is consumed in 1 second. And like this, if it is consumed for 1 hour, we say that what? 1 kilowatt hour. For 1 hour together, if it is operated in 1 hour, 3600 seconds will be there. when you multiply these both together, you will get 36 and 5 zeros you will get. Okay, here including the 6 decimal places. If you shift the point to this side, 3.6 into 10 to the power 6 joule, we are getting this, right? So this is all about electrical uh, energies, and this is the complete chapter we have covered in the very much short time. Okay, in the next upcoming videos we will have numericals. Okay, if you are thorough with that, it will be very much helpful for you to practice for your upcoming examinations. If you have any doubts, you can comment so that I can take up that topic and clear it to you.